Hello everyone, my name is Jim Barton and I'm a field engineer with solo.io, and I want to welcome you to this live office hours discussion. So one of the things we're seeing at Solo is a real growing interest in the use of WebAssembly technology to extend both our API gateway and service mesh platforms. The upstream Envoy Proxy has now released a WebAssembly filter into its mainstream, and Solo is supporting it in both our Gloo Edge and Mesh products. So today, because there's so much interest and it's growing, what I want to do is walk through an example of how to solve a real-world problem that a couple of our customers have come to us with, using both a more conventional approach with standard YAML configs and Envoy filters and so forth, as well as using our a WebAssembly extension filter that we'll be plugging into our Gloo Edge API gateway. And so this will allow you to see a difference in what it takes to employ each of these solutions, as well as some of the performance characteristics of each one. If you're interested in learning more about this, perhaps reproducing these results on your own, I'd invite you to take a look at the blog post that should be up on your screen right now, where we explore this topic in more detail. Today we only have about 30 minutes, and so we'll be moving fairly quickly. Feel free to enter any questions you have in chat or in our Slack channel for the conference, and we will try to get to those at the end of the talk here. Okay. So first of all, let's talk about the problem a little bit. So we've had multiple customers at Solo that have come to us recently who use our Gloo Edge API Gateway product, and they ask us questions like the one that leads off this post. So we have a security team. They want us to remove any response headers from our services that might indicate to a potential attacker that we're using Envoy as the foundation of our API gateway. So there's a couple of specific headers, a server header, and some headers that begin with X Envoy in particular that we would like to get rid of. So how can we address that? In fact, that it is a real problem. If you look at, for example, posts like this one that talk about preventing information leakage, one of the top risks that they talk about addressing here is removing things like the server header from your responses. Okay, so that's what we're going to focus on today, is getting rid of these indicators, excuse me, that Envoy is being used underneath the covers. Okay, so for prerequisites for this, we're just going to be using a GKE cluster, and we'll also be using our Gloo Edge Enterprise API Gateway to walk through this problem. And so we'll start just really basic stuff. We're going to take the HTTP bin service and we're going to expose that. In fact, we've already done that here in our environment. You can see the HTTP bin service is running, as well as all of the components for the Gloo Edge product are here running in this cluster. And what we've done is when we install this HTTP bin service, what it does for us is it creates what's called an upstream. So this is a Gloo Edge Kubernetes custom resource that identifies routable targets. So in other words, when we install this HTTP bin, now there's an upstream that's been created that allows us to route traffic to that automatically. And the way we do that is with another abstraction that's called a virtual service. And so we created just a very, very simple virtual service. Here are the key elements of it right here. You can see it accepts traffic from any domain and basically from any prefix, and then we'll route those requests to this upstream that was discovered for us. Okay, so very simple. So let's go through and let's run this. So we will send a request to that HTTP bin service, and it's just going to echo back what we sent in as part of the request, and then you can see also we're getting back the response headers and the 200 OK message. Now, a couple things you notice from an information leakage standpoint. What we're concerned about here are two of these response headers. So number one, we don't want this server Envoy header leaking out. We either want to obfuscate or remove that. And then we also want to remove this Envoy upstream service time header, since it obviously tips off potential attackers that we're using Envoy. Okay, so how do we go about doing that? Well, so as I said, we're going to cover a couple of approaches for doing this. One is the conventional approach that you would use with Gloo Edge, and obviously analogously with other API gateways as well. So we're going to first create a new version of our virtual service here. And in this new version of the virtual service, you can see this is the one we started with here. And we're going to modify that slightly to add these components. So we're going to remove the header, response header server, and response header Envoy upstream service time. You might be thinking to yourself, well, I'd like to be able to do that, say, with something like a regular expression, so I could just say, hey, give me anything that starts with Envoy. You can't do that quite yet with this interface, although it is something that's on the roadmap. However, you will see that we're able to do that with our WASM filter that we're going to create shortly. So just a little bit more generality that approach gives us at this time. So let's go and apply this modified virtual service spec to our cluster. And so you can see that's configured, and now when we run this, you will notice a difference. So before we had this Envoy upstream service time header, and you can see now we don't. Now you might also notice one other thing that perhaps disturbs you just a bit, and that is, so one of our objectives is to get rid of this server header that reports back that Envoy is being used. And you can see that is still being reported. So what's going on with that, and how can we address it? So what we're actually seeing here is Envoy controls that element of the response, and it will not allow the control plane to remove it unless you use another Envoy directive that basically tells Envoy that you want to pass through this server header, or potentially the lack of a server header in our case, through to the client. So what we need to do in order to activate that and basically instruct Envoy that we also want the server header removed as well is we're going to apply this patch to our gateway that basically provides this Envoy directive. So let's do that. And when we do that, you can actually see, if you take a look at the gateway component, you can see how that's been, you can see how that directive has been applied here. And now what you'll notice is when we execute this, you'll see that all of the undesirable headers that indicate that Envoy is behind the scenes here, all of those have been removed, and so that's what we're after. Now, one of the things that people are concerned about, actually, let me kick off a little quote unquote benchmarking exercise here. So this will run for a few seconds. We're just going to hit this cluster with 10,000 requests against this interface and see what kind of throughput performance we get. But one of the concerns people have with WebAssembly technology is it fast enough, right? And so that's obviously a concern that we want to address, since we are building our own custom code and applying that into the request path for these requests. So that's one of the things we want to take on as after we build our WebAssembly version of this. We want to come back and compare the performance we get with that versus this kind of standard filter configuration. So you can see here some basic statistics for this exercise. You can also see there were no errors. All the responses were 200s, all 10,000. And you can see that our baseline performance number here, let's round it off to 928 requests per second. So we'll come back and visit that again in just a moment. Now, next thing we need to do is we're going to take a look at the WebAssembly version of this same exercise. But let's reset a couple of things first, just to get our cluster back into the correct state. So let's replace our gateway settings back to the original, and then we'll also go back to our starting point virtual service, which just routes all traffic into HTTP bin without modifying any headers. And so if we do a curl, you'll see that just like we had at the beginning, we have both the Envoy server Envoy header as well as the upstream service time being passed through. Okay, so we're back to the starting point. Let's talk about what it takes to build this as a custom WebAssembly filter. So the nice thing is with the WebAssembly proxy runtime that's provided as part of Gloo Edge, you actually have a couple of language options. So you can use languages like TypeScript, which is what we're going to use today. You can use TinyGo, you can use Rust, you can use C++. So you have some possibilities there with others on the way as well. And we also provide a command line utility called WASME that allows you to do just basics of, hey, let's create a new filter that we can then customize. Let's build that. Let's publish it. Let's deploy it to our gateway, that sort of thing. So just to show you really quickly here what that looks like up front. So we're going to use WASME init to create our custom filter. You know, we can pick what language we want. Let's go with assembly script, and you can see there's a little skeleton that's basically generated for your project that you can use. So we'll be modifying a couple of the elements of this. We won't go through all the details just in the interest of time, but you can see that there's some elements here for managing the dependencies on the package, as well as for the runtime configuration of the package. We'll make some minor modifications to each of those, but then the core of this is here in the index.ts TypeScript file, where we're actually going to put the logic that's going to be applied as part of this WebAssembly filter. So let's dig into that a little bit more here. Here you can see the dependencies we have. This is pretty simple. There's more details on how to specify this in the blog post if you want to drill down on that. We also made a small modification here. This is where the bulk of our work went, and that is in this TypeScript class that's going to be responsible for removing the headers that we've configured from the responses. So if you really want to dig into this, you might want to take a look at the context class that supplies these callbacks, or this callback that we're implementing. There's a lot of interesting details in terms of kind of places you can plug in to the request path to do custom modifications to the requests and responses that are floating through. So specifically, the one that we're going to focus on is this one called on response headers, and you will notice that we have provided a couple of things here. One, we've provided a custom constructor for our class, and we've also provided a custom version of this on response headers callback. So we're basically doing two things here. It's pretty simple. First of all, in our constructor, we're going to establish an array of tokens that we want to remove from the response header. So we don't want to hard code this. We want to allow users to be able to configure this filter with a list of headers that they would like to remove. So basically, we take this input configuration. You'll see this in a little while. We split this up and we store it away in a set of an array of tokens that we're going to be looking for. All right. The other interesting bits are here with the on response headers callback. What we're going to do fundamentally is pretty simple. We're going to take a look at all of the headers that come in at this point in the response. We're going to walk through that set of headers. We're going to extract the key from each one of those and decode that key, put that into a string, and then once we have that key, that header key in a string, we're going to walk through all the list of tokens that we saved back up here in our constructor. We're going to walk through that list of tokens and see if we can find a match. So in other words, if any of these headers start with the value of the token, then we're going to remove that header from the response. Okay, pretty simple. You might be asking questions like, well, why not use something like regular expressions to do this rather than a starts with primitive? Well, assembly script, remember one of the goals of WASM is to keep this runtime absolutely as compact and secure as possible. And so there are a lot of the, let's say, more advanced features that you might expect with a language like JavaScript or TypeScript that aren't available. So for example, things like regular expression evaluation are not there out of the box. Things like closures that you might be used to using with JavaScript, that sort of thing. So that's why we have kind of this sort of primitive looking code here. But at the end of the day, it gets the job done. Anytime it basically configures a set of tokens, and anytime it sees a header that begins with one of those tokens, it removes that header from the response stream. Okay? All right. Hopefully that all makes sense. So let's show you. I'm going to skip over the build and deployment process. It's pretty simple. There are utilities here that that will allow you to build out your image, and then to actually push that image up to our hub. We'll talk about that in just a second, and then also to deploy that filter as well. Okay, so in terms of how you store and manage these filters, so this the WASM utility can help you with that, and it works very well in conjunction with a free service that Solo provides called WebAssembly Hub. You can go there today and log in and get your own account, and you can see what we've done here is this filter that I just showed you. We have already published this up to the registry, and you can see the versions that are out there and that sort of thing. So what we're going to do is we're going to deploy this filter out to our cluster, out to our API gateway, and then see what happens. Okay. So right now there's nothing there, as we said before. The only thing that's sitting there is just it's just a basic virtual service. You can see the two headers that we want to get rid of are still there. So let's go ahead and we will deploy. You can see, actually let me deploy the latest version of this filter, which is 1.0. And so you can see there's the path to our filter. We're going to give it an ID, and then notice we're passing in a config, and the config has two elements, comma separated. One is x-envoy, the other is server. And so basically we're going to look for any headers that begin with those two tokens, and we're going to remove those from the response stream. Okay, so let's deploy this, and you can see it doing its work there, deploying it down to the API gateway. And in fact, if we look at our gateway element here, you can see here is where the filter was deployed. We're also going to actually, let's just go ahead. Let's look at what we have at this point. So you look at what we have at this point. You can see the service time header has been removed as expected, but as we experienced before with the more conventional configuration, we still have the server Envoy header there. So what we'll do, we will, just like we did before, we will patch that. And when we patch that, you'll be able to see in the gateway component here, you can see the configuration has changed to add that pass-through value in addition to our WASM filter that we just deployed. And so when we try this again, now you'll see it behaves just like we expect. Both the server header and the Envoy upstream service time headers are removed. Okay, so that's a quick intro. Let me show you also we want to do the performance comparison as promised. So let's kick that off. That'll run for a few seconds. You might remember the first time we ran this, we got 928 requests per second with no errors from the original configuration. So let's see what we get this time. This time we also get no errors. You can see there's a little bit of degradation in throughput, 918 requests per second. So that's what, maybe 1% or 2 degradation versus the original. So the good news is very high performance, compared even to our native Envoy config, and definitely something I think that's worthy of your consideration when you're thinking about ways that you need to do custom extensions to your API gateway deployments. WASM is something that you definitely might want to take a look at. Okay? If you have any questions about this, we will certainly provide this link to the blog out in our chat, both on Slack and for this session. And if you have any questions, we still have a few minutes left, and I will be happy to take those.